when two chords intersect inside a circle, the product of the pieces that it's cut up into are equal to each other. So for example, this chord is cut up into the pieces 4 and 6. Their product, 4 times 6, is going to be equal to the product of the other two pieces multiplied together. This will be true anytime two chords intersect in a circle. And so this will allow us to write this equation: 4 times 6 equals 3 times x. The two pieces of each chord multiplied together equal each other. So solving this very simple equation, we get 24 is equal to 3 times x. Dividing both sides by 3 tells me that x is equal to 8 in this case. We can try a little more complicated example over here to the right. However, the same idea still holds. The product of these two pieces, the two pieces of the same chord, is going to be equal to the product of the other two pieces. So I'm going to use parentheses to make sure that x plus 2 times x plus 1 is multiplied correctly. I need to use parentheses around those two term pieces. That product is going to be equal to the product of the other two pieces multiplied together. So x times x plus 4. Again, use parentheses to remember to distribute. Okay, so the equation's a little more complicated, although it shouldn't be too bad to solve. I'll start with the blue side by distributing x. X times x is x squared. So I am ending up with something that's quadratic, and we'll see if we're going to need the quadratic formula or not as we go through this. I'm going to need to multiply these two green pieces together. I can do this a few different ways. I can FOIL, I can distribute as long as I make sure I distribute both the x and the 2, or you can use the box method, which is what I like to do. So just in case you need a quick refresher on how to multiply using the box method, I'll show you how I do that. X and 2 are the two pieces I'm multiplying together from the first parentheses, and then an x and a positive 1. So multiplying rows by columns, I get x squared, a 2x, a 1x, and then a 2. And then all of those numbers get pulled out of the box and added together. So I've got x squared in front, 2x and 1x add up to 3x, and then a positive 2. So this side also ends up being quadratic, or so it seems. As soon as I try to bring the x squared to the same side, we'll see right away though that they cross out. And so once again, we've dodged that bullet of having to worry about the quadratic formula, although in a couple videos we're going to talk about what to do in that case. So I guess what I'll do now is solve for x by subtracting 3x from both sides. I'm left with 2. And then, hey, the other side's done, equals x. So I've got my answer, just like that. Just to see that this did work and that this whole product idea still worked, let's go ahead and plug 2 back in for x in the original circle and see that everything multiplies out the way it's supposed to. So this piece is 4 then, because 2 plus 2 is 4. 2 plus 1 is 3. This piece would be 2, and then this piece would be 6. And so if I checked my products, these two pieces multiplied together equals 12. Of course, and that should be equal to these two pieces multiplied together, which it does. So, hey, cool, it works. Both products are 12.